Good morning. This is Professor Giuseppe Mascarella, and today I'm here with Jacek Laskowski, a prolific contributor to Spark 2.0, to talk about designing distributed machine learning system with the Apache 2.0. What is the challenge we're trying to solve? There is a major shift in computing. In the last 20 or 30 years, we've been documenting the logic of how applications should behave, and we have written hundreds of documents that are very hard to keep up. Lately, most of the people have come to a conclusion that it's way more effective to let the data and machine learning to predict how application should recommend something, should present to the user. That is something that requires data, but also requires an orchestration. And in this orchestration, we have three components of the challenge. One is that the amount of data is growing. If the Moore law was surprising everybody with the amount of processing power growing over time, well, the growing rate of data should surprise anybody even more, to the point that becomes almost the biggest problem. So on one side, we have incredible amount of data growth. On the other side, those data come from edge points, from manufacturing, from traffic, from social media, from other sources. Therefore, you need to start dealing with heterogeneous computing environments. The next level is that because of the opportunity to have virtual machine on the cloud, organization of hundreds of machines that are very often idle. So the optimization and the fostering the usage of all this CPU, RAM, heterogeneous database is what is called distributed computing that need to be managed by some technology. The third force that makes this change significant is that machine learning algorithms are becoming mature, reliable, trusted, and therefore they become the glue between the data, the computing resources, the information coming, and how they become valuable to the user. All this is coming together with certain challenges when you want to do this in massive scale. The first is that you need to start implement distributed pipeline. You need to look at data coming from multiple parts as a pipeline and be ready to think that tomorrow the data might be different, there might be multimedia, and you need to start thinking in that way. The second is that machine learning library can no longer be executed in the traditional way as a single-threaded application like with R and MATLAB. They need to be handling multi-threaded distributed computing. The third is that you need to optimize all this hardware and processing capabilities so that they synergistically work to scale out in computing. The fourth is that commodity hardware can make all this cost little. There are a lot of aggressive pricing plans, and from Amazon and Microsoft to Azure, where you can get the job done with little if you know how to shuffle computing power and resources in the right way. Fourth list, but not the least important, is that information are required in real time. And to handle data that come in streaming real time, you need newer technology integrated with machine learning and all the other topic. And all this need to happen, all this work need to happen while we have an increasing speed of execution. And the technology that today answer that kind of request is Spark. And as a matter of fact, in Spark 2.0, the Apache Association published a benchmark where the ratio is 1 to 110 on if you run a certain computing workload about logistic regression on Hadoop versus if you do Spark. It's 110 times faster on Spark. Well, if Spark has a promise to solve all these problems, let's go through and understand what is Spark, number one, what is Spark machine learning, and it's called MLlib. And let's use this. Let's choose a scenario, test mining, and use this technology. What is Spark? Apache Spark is a fast and general-purpose cluster computing system with in-memory data processing engine suited for modern data application. There are 3 layers in Spark. The layer that is closer to the user, that are the library of application programming API. And the first one is the Spark SQL, that process structured and semi-structured information, support SQL, windowing commands of ANSI 2003. And the next one is the language support. Scala being the most dominant because it's the native language of Spark, but to support the largest amount of possible programmers, Scala has library to support Python programmers, R programmers, Java programmers, and lately we found out in the Databricks website that even C#, F# are supported. The third library is the one supporting the streaming needs. The fourth is the machine learning, and the fifth is GraphX, supporting things like social networks, graph. The middle layer is called Spark Core. This is where you insulate the needs of managing in-memory processing a large amount of data, and also manage the relationship with the source of data. Fortunately, Apache Spark supports a wide variety of them. Can run standalone, but can run in synergy with Hadoop Yarn, Apache Mesos, Amazon S3 file system, HDFS, Azure file systems. So that is what is Spark. Now, Spark is a software that you can download for free from the spark.apache.org website, because it's 100% open source and is hosted by the vendor-independent Apache Software Foundation. When we say vendor-independent, we have 2 categories of vendors. There is vendors like Databricks, that is part of the group that develops and enhances Spark in the Apache Foundation, but at the same time as a commercial operation called Databricks, where they enhance the software and add support, and because it's under GNU, all the enhancements go back to the Apache Foundation for possible inclusion to the next release. Then you have other commercial vendors like Microsoft Azure, Amazon, IBM, that make their own implementation and include services to enhance the interoperability with their services. All this makes Spark an industry standard that with a great future. But what is probably the most remarkable part of Spark is the story of the early adopters. Netflix being the most famous, their incredible, effective, competitive weapon that is their recommender is based on Spark. At the same time, we have other companies like Washington Post. They use their recommendation engine based on Spark to recommend the right article to the right reader. Yelp uses this to do a matchmaking between advertising and reader, and Hearst Corporation uses this to manage the streaming of data of information coming from 200 website properties and optimizing the distribution of the information article to the right user in the right place, understanding what is trending and momentum in real time. So we have both industry support and incredible success stories. At this point, it's worth to dig down into understanding Spark architecture, because it's worth it. Spark Core, that is the layer in the middle that supports the library and the interoperability, but at the same time as a role in itself, define the RDD data abstraction, means the capacity to look at data as an object that we're going to define, and provide the in-memory computing capabilities. to do in-memory computing capabilities across distributed virtual machine and assets, you need to work as a clustered deployment engine that doesn't overlap but is synergistic with Hadoop Yarn, Apache Mesos, and things like that. But when we focus to the core, is how does it work in distributing those computing, we need to focus on RDD, resilient distributed dataset, that are in-memory, partitioned, cacheable, parallelized, typed set of data. The core does the action of shuffling those data across the computing resources available, and uses three components, the DAG scheduler, the task scheduler, and the scheduler backend, to orchestrate all this. But this is something hidden to the user. The user sees API that take advantage of distributed computing without extra effort. Let's move now to one of the most important library in Spark, that is the machine learning library. This is an environment that has been designed to process petabytes of data. From a software point of view, it's a library that you download from org.apache.spark.lib and present itself as an API. The amount of algorithm available is stunning. On the left side, you see the list. But the interesting part is the right side, where you have independent vendors outside the Apache Foundation that keep adding algorithm, cutting-edge algorithm, that once they are compliant with the Spark framework, they automatically take advantage of all the distributed processing capability of the engine. So you have pretty much the opportunity to either post your algorithm as R as a single threaded limited, or post here and have access to mission critical application and incredible amount of power and capacity to manage the heterogeneous system. I expect that Apache will attract more algorithm publisher than any other platform, and this is already happening. Let's move to the third part of this session. Let's use Spark. Let's choose a scenario, test the classification, and let's go through the logic, the math, and the code. So the problem at hand is, given a text document, think a press release, a newswire, classify it. And we have two categories, A and B. Either it's a scientific article or it's not a scientific article. The goal of this machine learning experiment is to find a decision boundary, the model. The algorithm we're going to use is logistic regression, that is a binary classification. It's either white or black. It's 0 or 1. Either belongs to the domain of scientific or not. Now, if you have those press releases coming, how do you know if the next press release coming, or actually the one that just arrived, belongs to the domain of scientific or not? You need to have what is technically called some features that help classify. And you can say, if the word kernel, compiler, and so on is present, it's a technical. Well, that's one of the possibilities. There are other things need to be present. But for simplicity in this illustration, I have chosen two features. One, on the y-axis, is that there is a mathematical formula, and on the x-axis, that talks about money. So if you have an article that has 20 mathematical formulas and only few discussion about money, probably it is an article belongs to the scientific domain. Vice versa, if there is a lot of mention about money, a little about mathematical formula, that probably belongs to non-scientific. But this is just a choice I made, but I would prefer to let the algorithm to work on this. Now, from a coding point of view, all this exercise is to enable the next press release be analyzed and classified into two classes of objects. There's object as scientific, as you can see in the right and the object not scientific. And from a Scala point of view, you pretty much get ready to say there are two traits. The trait of scientific, this is the one object, and the other object. The reason why we are define this as an object and we're using Scala as object-oriented programming is that the object can scale to heterogeneous data. Today is a press release text, tomorrow can be voice, can be video, can be images, can be multiple things. So you build something that has a future to scale across computing power, data set, anything. That's the power of using a very advanced language like Scala. Let's walk you through the process to go from general industry terms to Spark and specific what you're going to see in the code in the demo that is coming. From an industry point of view, our machine learning experiments is a series of steps: load data, do engineering features, choose which features is relevant, and prepare them for the model to be trained. Then score the model. Is this classification's way to divide effective? And then offer this as a service. In the Spark world, the data are defined as a data set. The feature engineering are called transformer. Means that you take data in one format, you clean, you prepare for the algorithm to do what is called here a fit. Means you fit a mathematical formula model to do the prediction, the decision. And then you evaluate and tune, those are the name of the functions, and all this can be packaged for future consume under PMML or Levy. Those are external packages because in reality Spark Core saves those models as a set of files that will be processed when called by Spark. But in a modern experiment, you need to think about REST API calling those services. That's why we have addressed this part. Let's move on now to the third column, that is our text experiment. So we create a data set, then we do what is called tokenizer and hash terms. Means that we transform text into array of words, we transform the words into entity that can be processed by the mathematical algorithm. At that point, we feed the logistic regression and then we evaluate. You see here a red box. That is the setup to talk about a very important concept of Spark 2.0, pipeline. Pipeline is the grouping of workflows that includes several stages. Here the stages we are packaging is the T for tokenizer, H for hash, LR for logistic regression. So the stage we're packaging here is we have a label, the object that you saw before, either a scientific or not scientific. We have a text that is a string or character transformed into words as an array, so sequence of strings. Then you pick the features as a vector that can be fed to the algorithm, and the algorithm produces the object of prediction. Let's move now to deeper level details. And we do not expect that you become a Scala programmer in this session, but we expect you to have an understanding of the beauty of Scala so that you can think about investing in studying, understanding, training yourself more into Scala and Spark. So when we talk about a transformer, a very fundamental element of a machine learning experiment, we have three steps in Scala. Import the library, define the object, and transform. So if you see on the right side, import the object is pretty much you import the library from the Apache website. You define the object that is tokenizer, and you give certain parameters of what is an input and what is an output that, as you can see, set output column as words. And then you execute it. You do the transformation, and the transformation produces a training.df or data frame. Now, what you had in input was a schema as a text, if you see at the bottom. after the transformation, you still have a schema, but it's a schema now of words that is useful to be processed by the next transformer. So we are still in the area of transforming one schema to the other, and therefore the word of transformer is because you're still remaining in the same concept of schema to schema. Now let's move to another concept, that is the transformation of dataset into a model, and the section is called modeling. Here you have 4 steps. You import the library, you instruct the object of the algorithm, a point 2, where you give it some information like I want to limit the iteration to 20, and so you're preparing that. The third is you create a pipeline. It means the workflow. It means that to get this experiment correctly executed, you gotta do this sequence: a tokenizer, a hashing, and a linear regression. And finally, you execute the model by running pipeline.fit that generate an output that is the training set. At this point, I would like to share with you a demo, and let me introduce one of the most prolific contributors to Spark, Giuseppe Laskowski. Giuseppe, would you please share your screen with your demo?
Yes, thank you, Giuseppe. I'm sharing my IntelliJ IDEA development environment with Apache Spark. Can you see it, Giuseppe?
Not yet.
Okay, it's being loaded, so it might take a while. Okay. Yeah, still loading. Share screen. You are about present now. Okay, so we need to wait.
Sorry for the viewer. A little bit of patience. We're gonna be able to.
I'm still seeing loading on my screen, so it may take a longer while to have this. Yeah, it won't work, I believe.
Okay, so let's proceed with the screen we have here. What you see in the screen is Scala code, where all the concepts that I illustrated in the PowerPoint come together in a sequence of commands that will complete the experiment. To really master how to extract Spark to create your application, you probably might want to take a class. And what you just saw today is just the introduction. So we talk about designing distributed machine learning system with Apache 2.0, and we went through the sequence of what is Apache Spark, Spark machine learning library, the scenario. There are some classes where for 3 days you're gonna get a hands-on experience on Spark 2.0 and various scenarios. We also offer a corporate upskilling program, typically for data analysts to become data scientists, where we combine social learning with Yammer, webinar, and analytics. And for more further information, you can contact me, Giuseppe at Value Amplify. You are going to be able to see a recording of the demo as a separate video file. And if you are watching this on YouTube, look for Spark 2.0 Value Amplify demo. Thank you so much.